Okay. Now we are presenting our today's host. Thank you, Maggie, for having us and spending your time and teaching us about the computer vision. I'm really excited to be here, and I'm passing on to you.
Thank you. Hi, everyone. I will start sharing my screen. I think you might need to stop sharing your screen first before I can actually share mine. Thank you. Great. Can everyone see my screen?
Yep.
Thank you. Just making sure. Great. So I'm excited to be here again after last week, and this is the part 2 of Introduction to Computer Vision. So this presentation will be slightly more technical, as last year was a really more basic introduction, but today I wanted to show you that a lot of the coding related to this isn't actually that difficult, and if you understand the principle of how things work, then the coding part isn't the hardest part, and a lot of people, I mean, most people can actually do it pretty easily if you know how to code in Python. So first, a quick recap from last week, or for some people who maybe were not here for part 1. So last week, I showed and explained different computer vision tasks and what computer vision is. So computer vision is a subset of artificial intelligence and machine learning, where we develop algorithm models that are able to extract features from images or videos to then analyze them. So for example, there is classification, which is the process of categorizing images into one of several predefined categories or classes or several. So for example, in the case I showed last week, we had a model that can classify if an image is an image of a dog, a cat, or a clownfish. And then object detection, which is the task that allows us to identify instances of object within an image and provide a bounding box around each object. So you can see it on the screen here. It's basically saying, where is the dog on the image, and put a box around it. And then segmentation, which is partitioning an image into multiple segments or a set of pixels that belong to different classes. I like to think about segmentation as classifying every pixel on the image. So that would be for semantic segmentation. But even for instance segmentation, it's classifying and detecting objects at a pixel level. So it's for tasks that require a really precise detection. So if you think of medical imaging, for example, where we're trying to segment tumors, for example, or specific parts of the brain, you would be using segmentation because you need to know exactly the contours or where things are and not just a box. Right. So metrics is how do we evaluate our models and how do we make sure that they work correctly? Let's see, I'm going to introduce some of the most used metrics here, the ones that I actually use most of the time in my current position and all my position before. But a lot of them are pretty visual, as I'm a pretty visual person. That's probably why I'm in computer vision. But there are a lot of different metrics too with formulas, but I wanted to start with this one. So the confusion matrix is a matrix where you can see on the right side of the screen, you have the actual classes and the predicted classes. So for example, if I look on the left side of the screen, the true labels are A, B, C, D, E, F, and then the model will predict a label A, B, C, D, E, F, and we have to make sure that the model predicts the right label. So for example, if we look at the first column, where we see we have 13 occurrences where the predicted label was A, and it was actually the true label, sorry, was A. But for 3 different samples, it predicted that it was the label A, but it was actually label B. So there's a false positive here. And you can see that by also looking again on the right side of the screen where it shows different true negative, true positive, false negative, and false positive. And obviously the goal here is to have a perfect diagonal. And that would mean that all of the predicted labels were the true label. So I like this one because you can see that if you don't have a perfect diagonal and if you have a lot of like clutter everywhere, it's pretty obvious that the model is not performing well, and it's kind of a really easy eye glance metric that I use. And also you can dig into it and see what label the model might be predicting often that is incorrect. So for example, in that case here, I would look at it and I would see that, okay, the label C is often predicted as B. We might have some errors here, and then we can go and check our data set, make sure that it's correct, and then try to understand why this is happening. But it helps narrow why the model is not performing well, and we can go and really picky look at things. So, and we'll be looking at how to create those. So then the more usual metrics that you will hear about is precision, recall, and F1 score. So basically, I put the formulas on the left side here. You can go and look at the actual formulas, but for that case, I don't think that's the most important thing to know. The most important thing is to understand what these scores are and what to do with them. So basically, precision is the true positive over true positive plus false positive, and recall is true positive divided by false negative and true positives. But what does this mean? Basically, a good precision means that the model rarely makes a mistake when it predicts something. So most of its predictions are correct, which is great. That's what we want to know. But a bad precision means that the model is often making mistakes. And so it's predicting a lot of the positive prediction are wrong. So in that case, it's going to be over predicting things. And that's not very good because if it's predicting, for example, a lot of defects on a board or lumber board, which is an example I showed last week, then we're going to think that the piece of wood is really bad when it's maybe not. Then the recall metric is when it's good, the model is great at finding and correctly identifying the most actual positive cases, but when it's bad, it's failing to identify them correctly. So it's missing a lot of true labels. So this one is also bad because we might be missing really important information, but at least we're not over predicting things. And then the F1 score is sort of a combination of precision and recall. So I really like to use the F1 score. I did put a formula here. But this one gives a really good overview of how the model is performing since it's a mix of precision and recall. So basically a good F1 score, we know that the model has a good balance between precision and recall. It is both accurate in its prediction and good at finding most of the actual positive cases. So it's the perfect world. And a bad F1 score, probably the model lacks balance between precision and recall. So then we might go and see which one is actually poor performance, precision or recall, or maybe even both. But for example, if the recall is low, again, it's missing a lot of actual cases. And if the precision is low, it may maybe be predicting incorrect predictions. Okay, so I'm going to be showing some live code. So hopefully that will work well. So that you can then go and you use the notebook. Maybe I can share the link to this notebook later on so that you can go and test it yourself. And it's to show that you can get started with something really easily, just a couple of lines of code. So I'm going to be starting with classification. And a data set that is really commonly used in computer vision is the NIST data set, where we have images of handwritten numbers and we're trying to predict which number it is. So let me jump to the notebook here. So here I'm using Google Colab, which is really nice because you can go and run on GPU for free. And here I do think that I have the premium version, but so I have access to bigger GPUs, but you can really run things with the free version. directly. So first, what I do usually is I go here, do and change the run type. And I check that I'm using a GPU because usually you want to run computer vision tasks on GPU so that they run faster. It can be run on CPU, but it will take a bit longer. So it's great. I'm using the GPU. So I'm going to go and install some packages. So the first one is called Ultralytics. And this is a great resource that you should go take a look at. They have really great tutorials and function that you can use just out of the box for computer vision. So I really like to use this one. Then I'm going to add some more imports. So usual ones for computer vision, which is PL to image to visualize and load images. Matplotlib is also used for visualizing. OpenCV. NumPy is for handling matrices in Python, and then some specific function to display things in Google Colab. The next thing that I'm going to do here is that I'm going to check if I have access to a GPU by running this command, NVIDIA SMI. And it will, if it doesn't have a CPU, it won't return anything. If it doesn't have a GPU, sorry, it won't return anything. But if it's connected to a GPU, it will return and give some information. So for example, here I know that I'm using a Tesla T4, and that's what I wanted to double check. And you can see it here too, a T4. Great. Now the more interesting part. So first, I'm going to load a classification model that is pre-trained, so I don't have to do anything for it. I'm going to use the YOLO package, well, the YOLO function from Ultralytics. So you can see here, I imported it from Ultralytics. So I'm going to load that model here. Can close this for now. Great. So this, the model classification that I just loaded, is a pre-trained YOLO V8 classification model. So by pre-trained, it means that it already has been trained on ImageNet here actually. And so it already knows a lot of things. So we're not starting from scratch here, and we can use this model out of the box that easily. And you can see here that I called the classification model because I put the CLS here. And it's .pt because it's using PyTorch. So that's something that I advised last week to take a look at, but I will have a slide at the end where I show some resources that I think would be good to take a look at if you want to know more about computer vision and do it yourself. And PyTorch is a great framework to use. So then we're going to train our model. So if you remember last week, when we have a data set that is ready, so here it's the case, the NIST data set is already ready. We have images that are linked to images of handwritten digits that are linked to labels of numbers. And this is how it's organized already in Ultralytics. And so I'm going to be training, meaning I'm going to teach the model architecture how to recognize these classes. So only, so I'm using the model here, I'm doing train, and I'm doing only 20 epochs. Usually you would go for a bit more epochs, but this is a live demo, so I'm not gonna go let it run for forever. But you can see it's really easy to run at first. Didn't have to do a lot of complicated coding here, and you can see here it's going through every epoch. So there are 20. I'm gonna let it run. Right, and so it's done running now. And you can see it's telling me already some information. So I can see I have the confusion matrix available somewhere and fitness, and I have some results. It's not super well organized visually here, but we can go and take a look at it better. This was done on the validation set. So usually we keep some data for training, validation, and testing, like I said last week. And this is what it's using here. It's using the validation set. So we can see that our accuracy top one, which is our number one class, is at 65%, and top five is at 97%. Accuracy is, I realize I didn't put this one in the slides, but the accuracy is just the percentage of correct prediction over the number of actual classes. So if I have all the images or have the correct prediction, I'm going to have 100%. If only 50% of them are correct, then I'm going to have 50%. So let me test it on one of the images from the test set. So if I go here, when I loaded the data set here, the minutes data set, it actually downloaded it here in the folder data set, and I can go and you can see I have a test folder here. So that is what I'm using here. I'm going to the test folder and I'm going to check one of the images labeled as 0. And you can see here all of the subfolders in test and train are organized as subclasses, as labels. So we have 0 to 9, which is the handwritten digits. And this is usually how classification datasets are organized. You have train validation test, and you have the name of the labels with the images under these folders. It's pretty straightforward organization usually. So here you can see I have the 0 image, and then I'm going to run the model that we just trained, so model classification. I'm going to give the pass to the image test, and I'm going to ask it to give me a result. So here the results is going to be saved in that variable. And if I run it here, it's giving me a bunch of information. So there's no boxes, no key points. Don't really care about this. I want to know what was the predicted label. So let me go here and I run this. And so here it's telling me that the top one class predicted was 0, which is correct. We wanted to have the predicted label 0. And here it is actually not giving me the one I wanted, but it's giving me all of the information, but the top one is 0. So I know that the class predicted was 0. So this is correct. So now evaluation. We can also use the ultralytics package to run evaluation in a really handy way. So you take your model, you say .val, the data set, and the split. You want to use the test data set to do the evaluation. Then I'm going to get the results. So I have them here too, but you can go and see them better here. So again, top 1 predicted classes is 65, top 5, 97. And the one that I told you I like the best usually is the confusion matrix because it is very visual. And I can see that I have a pretty nice diagonal. I do have some incorrect prediction here and there. So that would be something that would be fixed by training the model a bit longer and or adding more classes. But you can also see, so this one is the unnormalized confusion matrix. So number of actual classes and number of actual predicted classes, but you can also normalize the image, the confusion matrix, and we'll have normalized. Actually, this is not the normalized one. Let me fix this here. You can go and create a folder in here where you can go and see. So here, normalized. Okay, that looks better. If I had it bigger, you can see that here it's predicting 1, so 100%, 100% of the classes were correctly predicted. Great. So the next step, we just did the classification. The next step is to see how object detection would be done using the same package. I'm going to close the classification section and go to object detection. So object detection, again, we're trying to detect and classify the objects on images. So here, I'm going to be loading a YOLO model again that is pre-trained, but I'm not going to say it's classification because the default one is object detection for YOLO. I have my model and I'm going to train the same way, and I'm going to train it on 5 epochs. Actually, sorry, it's not the same way because I'm going to be using a different data set here, which is the COCO data set. COCO 128 is a smaller data set than the big Cocoa one. So for demo purposes, it's better to use right now. But it has images of random things in the world and the bounding boxes around them with the correct classes. So that's the one I'm going to be using here, and for 5 epochs only. And when I do this, you can see here that it downloaded the dataset Cocoa 128, and I can go and see it. I have the images and I have the labels. So here I'm going to have JPEG files, and here I'm going to have text files. If I open one of them, you can see that I have the class ID and the coordinates of the bounding boxes. And this is something I covered last week, where I was showing how you can say the different coordinates of bounding boxes. In that case, we have center point, so center X, Y, and the width and height of the bounding box. Great, our training is done. And it sent me all of the metrics for the validation of all of the classes, the validation test for all the classes. So you can see the Cocoa dataset has a lot of examples and classes. So here it's telling me all of the results for all of them. And this is a dataset that is really commonly used and available, that you can go and play it with yourself. So I think it's a great one to look at. And you can see, for example, it has a lot of example of cat and dogs and birds. So I'm going to be using it to, to classify to run on one of the images we saw last week, which was the image of the 2 dogs that I have here. I'm going to show you the image as a reminder. This is the 2 dogs that we have on our image. And I'm going to try to run the inference on that image. So I'm trying to run the new model I trained right now on that image and see what it predicts. So now I run the model on our image. I have my predictions. If I look at them, I can see that I have some boxes elements. I have the names of the classes that are supported by the model. Lots of information, but what I care about right now is the boxes, so the predicted bounding boxes. So how do I get those? Oops. I go into the predictions. I only have one right now. I go into boxes, and then I can get the coordinates X, Y, W, H in the element boxes. And I can see that the classes that were predicted are ID 16. Which is the ID for 16, and the spoiler alert here probably is that it is the class ID for dogs. But let's see it here. So here I'm doing some conversion of the different coordinates to display them on our image using OpenCV. So usually you would be able to find code like that to use with OpenCV pretty easily with Python, just to overlay bounding boxes. Pretty straightforward, copy paste usually. So you can see here, it was able to predict that we have 2 dogs on this image and was able to put the bounding boxes around them. So I think this is a really good example to show you that you can go and create an object detection model in less than, I think it took me like 10 minutes. And I've been talking a lot, so if you don't talk and you just run the code, it takes, I guess, 5 minutes, and you can just go and do it yourself right now and predict all of the classes that were in the Cocoa dataset. And this is a small Cocoa dataset again, so a lot of different classes that you can go and create yourself. And then let's do some evaluation again. So let me grab the correct model that I just trained. If I go here, it's called model object detection. It's the one that was trained here. Go here, I just replaced this was incorrect. And I'm gonna run the evaluation on the val dataset this time. And we'll get the confusion matrices again from from our run. So here I get all of the metrics for every single class. So you see it is a lot again. For dog, for example, if I look at this one, I can see that I have the number of instances in the test set. I had 9 examples of images of dogs with the bounding box. And my precision is 70%. The R score is 89%, and then MAP 50 is this is a metric that is often used in object detection, is at 90%, which is pretty good for only running a few epochs. And I apologize, I didn't do a really good job at explaining what the MAP 50 is, but I would encourage you to go and look it up. Sometimes it's a bit hard to just explain what one of these metric is, but it's a pretty common one used in object detection. Close. Usually I would use the precision here as well, so we go for one of those. And then again, I like to go and look at the confusion matrix. So here, train, and it's actually train 2, my folder. What I'm doing here is I know that I just ran some evaluation. So I go and I know that the run I just did was detect, not classify. Classify is the one we just did before. And I know that I run the training and then I run the evaluation. So I know it's the train 2 folder. That's why I replaced it by 2 here. And you can see here I get a giant confusion metric that looks pretty good, but obviously you would go and dig into it a bit more than what I'm doing right now. But this is the not normalized one. So I like to use the normalized one where I can really see what's happening. So it really make it homogeneous. And you can see that the model is doing a pretty good job. It is over predicting, I think, some classes in the background. The one at the bottom is the background, but I would obviously here go look at it with the full lens and really explore how it's working. But for 5 epochs, this is what you can get in 10 minutes. So we've seen object detection now. Going back quickly to my slides. So again, we were able to detect the 2 dogs on the image, detect and classify the 2 dogs on this image using the Ultralytics pre-trained object detection YOLO V8 model that we did fine-tune. So fine-tuning means that we trained it a bit further with the dataset Coco 128, which has a lot of different classes, images from the diverse random things in the world, usually a lot of animals, people on a motorcycle, airplanes, kind of like everyday life imagery. And we were able to run some really basic evaluation and get some first metrics. So now let's do it for segmentation. Okay, so same as before, I'm going to clean up things a little bit here. I'm going to be calling the YOLO V8 model again. And just here to mention, I know that last week I mentioned that the YOLO model is you look only once. It's usually used for object detection. But this model has been extended to do classification, object detection, and instance segmentation with the Ultralytics package YOLO V8. So that's why I'm using this one here that can do, it's the same backbone architecture of the model, but then has been extended to perform more tasks. So that's why I really like this one because it comes really in handy. You don't have to overthink what model architecture you're using. You know that you can just go grab that one and make it work pretty quickly. So it's really good for proof of concept. If you want to go and do some more detailed segmentation, maybe you can then go get another model architecture like UNet. But this is a really good way to get started. So here to get the YOLO V8 segmentation model, I call the seg model .pt, so PyTorch. And I'm going to train it on the Coco 128 dataset again, but the segmentation one. So it will be the same images as before in the training set, but the labels will be masks around the objects rather than bounding boxes. And I'm going to train for 5 epochs again. epochs or iteration throughout that the model goes through to learn things. So the more the better usually, but you don't want it to last too long because then the model start to get confused about things. So usually I would go for about 100, 200 epochs, depends of the project. There is something pretty good to know here, which is called the early stopping, that will stop the model when it's not learning new things. And so it's like reached its best capacity and it will stop when it's reached that capacity. But let's not get lost here. I'm going to train that model here. And then once the model is trained, so here we can see it started, I'm going to be running it on one of our image tests, so the same one as before, the dog one. And I'm going to say that I want only the prediction that have a confidence score higher than 80%. Every single prediction has a confidence score, and usually the threshold is at 0.5, I think, by default. So I like to sometimes go and say, okay, I want to filter the results and I only want the one that are higher than 80% confidence. So I'm pretty sure I'm only getting really good predictions. Yeah, so the training is done. It's gonna give me some information about what had just been trained like before. You can see we have new metrics showing up here, which are masks. So we have a segmentation metrics here. Same classes as before. See our dog class. We still have 9 examples in the test set. And then we have our prediction on our dog image. So I'm not going to go dig too much into this, but I'm going to take a look at the masks prediction this time. So the masks are the segmentation predictions. If I look at the shape here, I want to see if it's the shape of the input image. I can see it's slightly different. So here I had to do some resizing of the images so that they can match the original input image and the mask. And whenever I send that notebook, you can see and really go through each line, but it's mostly resizing some images. So it's not too hard. And I'm going to go and display the results that we have. Wait, I don't know why my images are giant today, but you can see that the first dog was predicted pretty well, the segmentation, but it thinks that it's a bear. And then the second dog, I didn't go through it. Let me go to my slides because my screen is being a bit weird. Okay, and the second dog was correctly predicted, but the class was correct as well. So you can see here that probably we would need to train the model a bit longer so that it learns that this is a dog and not a bear, which I thought was pretty funny. And this is the end of my notebook here. So you can see here that now we did a segmentation, instant segmentation in that case model really quickly too. Sometimes when you deal with computer vision, you have to deal with some sort of shape issues, but a lot of the time it's mostly resizing the images and knowing that you need to use packages like NumPy or OpenCV like I did in the code. So that's a good time now to see all the different tools that you should know about when starting a career in computer vision. So the development tools, I've already mentioned PyTorch is a great one. Another one that is pretty similar to PyTorch is called TensorFlow. These two are to design and implement machine learning computer vision code pretty low level, pretty high level. Sorry, it's like you can go and create your own architectures. Then Ultralytics is the package that I just used, where you have a lot of really easy things that are already implemented for you. You can go and run your own model and you can train your own model really easily with just 2 lines of codes, I guess. Sklearn is well known for machine learning mostly, so often used for regression tasks, but it's also something good to know for computer vision. And then Hugging Face, probably not of you know about them, but I think they're great. They have a lot of resources. Visualization, Matplotlib, and Plotly. So this is to display the graphs, the confusion matrix, and the different images. Then tracking and monitoring. So what I mean by this is whenever I train the model, I get metrics throughout all of the epochs, iteration of learning. And so you usually want to track and monitor that your model is learning. And so great tools for this are weight and biases, ClearML, and TensorBoard. Then I got this question last week. How do you go and label your own data sets? So there are a lot of labeling platform tools. And those are my favorite ones that I have used myself. So that's why I put them here. So RoboFlow, CVAT, Labelbox, and Anchored. Some of them you do have to pay for them, but I know for sure that RoboFlow and CVAT have free version of their app. So that's a good way to get started. And RoboFlow has a lot of great tutorials, content on YouTube. So really recommend you check them out. And then if you want to get started with some data, but you don't want to go take pictures of your dog and label all of the instances of your dog, you can go find some data sets on Kaggle. Then there's the Deep Lake ML data set. Those are really great for computer vision. And Hugging Face also has a lot of data sets that are available. And then at the end here, I added some good to know things that I usually would look for in a CV when I'm looking at hiring new people. So this is really important to know, I think, because it's more computer sciencey, but this is really useful when you implement machine learning, AI, computer vision algorithm. So the first one is Docker. That's for environment setups, and that would be another entire workshop. So you can go and check it out. There are a lot of great resources on YouTube for this. And then the last one is AWS SageMaker, so the notebook and the estimator. I would recommend looking at the estimator. That's something that is often used in industry. AWS isn't free, but you can get some free credits to get started with. Okay, and lastly, some resources. So I just want to end here with some educational resources that I like. So as I've already mentioned, the RoboFlow YouTube channel. The machine learning shorts YouTube channel is something that I created, I think 3 years ago. I had some more free time at the time, and I made some short videos about machine learning. So they're still there. I am not publishing new videos anymore, but the ones that I uploaded at the time can be useful to you, so you can go and check them out. Then there are a lot of great blog posts on the Active Loop website. Active Loop is a part of the Deep Lake tool that I mentioned before. And then some of my favorite AI resources, they are not always computer vision related, but I think they are great tools to stay up to date with all of the new AI things that are happening every day. The first one is What's AI by Louis-François Bouchard. That's a YouTube channel and podcast. Then the AI breakdown is also YouTube and podcast. I really like this one. The AI Papers Academy is YouTube. And then if you're looking for some volunteer short-term AI projects, I would really recommend you to go and check out Omdena. I did several projects with them. I think I did 3, and I learned a lot. And this is a really good way to get started. And if you have maybe 10 hours a week that you can volunteer some of your time, that's a really great way to learn how to implement machine learning projects with real-world data. So yeah, I think this is all for today.
Thank you, Maggie. We have some question in the chat. One is asking, can you please throw some light on the CI/CD tools that you use?
Yes.
To post it in the chat, yeah.
What do you mean by CI/CD in that sense, Sveta? I don't know if you can answer back to the Q again.
I think she's asking like the testing
The
pipeline.
testing. Okay, yeah. So that really depends. So usually I would, so like what I showed here with Ultralytics, I would use some of the evaluation components they have. I also will use the tracking and monitoring with some custom metrics sometimes that you can develop for the project that you're working on and then visualize them in weight and biases or ClearML TensorBoard. And then once you have a model in production, it's kind of a different story. You do have to do a lot of custom metric implementation and custom monitoring system, but using often the tools that I mentioned, weight and biases, ClearML, Ultralytics again, and would use probably OpenCV and NumPy a little bit depending on the project.
Thank you, Margaux. We have another question. Is Apache Spark a tool that's typically used?
No, that's not something I usually use.
Yeah, Apache Spark is usually used to build like ETL. So I think
Yeah, that's
ask
not
that
something I use.
question. I think that's all. If we can just share the link, that's all the big questions I
Yes.
can see going on. But thank you, Margaux, for your time. We've learned a lot. I love the doggies and puppies, and they have a big heart like a bear. So I guess in a way, Python did see what's inside, not just outside.
That's funny. Where's the best place to share the notebook? I guess I can share it here in the chat
In the
to
chat, yeah.
everyone. Yeah,
Yep.
everyone. So that, okay, that should work. Please let me know if it doesn't work. Yeah. Also, you can, forgot to mention, but if you want to reach out to me, you can reach out to me on LinkedIn. You can find me at Margaux Masson-Forsythe. I'm pretty active, so I would answer to messages if you tell me you were at the session. It's easier for me to filter and answer more easily. But yeah, if you have any question about computer vision projects or how to get a bit deeper in the subject, I know there are a lot of things I haven't covered, but I think there would be another workshop again.
No, we
Thank you
really
for
enjoyed it. Thank you. Thank you, Margaux.
Some people are wondering if you could share the slides from the session.
Yes, absolutely. Let me do that right now. I'm going to share the ones from last week too. So this is part 2, but let me send part 1 as well. Oops. Thank you. I sent it to Rajashi personally. My bad. Okay. We have part 2 and part 1 slides.
Thank you so much, Margaux. That was a very interesting session.
Thanks. I'm happy that you guys liked it.
All
Yeah,
right.
same here. Thank you.
Thank you everyone for joining. And once again, thank you, Margaux, and also thank you, Roger Shi, for moderating today. Okay. Bye, everyone.
Bye, everyone. Enjoy. Bye-bye.